Hi, I'm Malini Anandraj, Assistant Professor, Department of Science and Humanities, Chemistry Division, RMK Engineering College. In this video lecture, let me explain about the electrode potential. The tendency of a metal to get oxidized or reduced when it is placed in a solution of its own salt is called electrode potential. Origin of electrode potential. When a metal is placed in a solution of its own salt, one of the two processes are possible. Either the metal atoms go into the solution in the form of ions, that is, M gives Mn plus N electrons. There is a loss of electron when the metal atoms go into the solution in the form of ions. Or the metal ions from the solution may deposit on the metal. Mn plus N electrons gives M, where there is a gain of electrons when the metal ions deposit on the metal. For example, let us consider zinc electrode placed in a zinc sulfate solution and copper electrode placed in a copper sulfate solution. Almost all the metals either lose or gain electrons in order to attain a stable state. Here, in this case, zinc electrode, when it is placed in zinc sulfate solution, it is ready to lose electrons in order to form Azactin 2+ ions. Whereas the copper electrode placed in a copper sulfate solution, here in this case, the copper ion gain electron and gets deposited over the copper electrode. When the zinc electrode forms the zinc ions which pass into the solution and thereby the zinc electrode acquires a negative charge. On the other hand, when the copper electrode placed in a copper sulfate solution, the copper ions gets deposited over the metal and thereby the copper electrode acquires the positive charge. The negatively charged zinc electrode attracts the positive ions from the solution and positively charged copper electrode attracts the negative ions from the solution, and hence there is a setup of electrical double layer of either positive ions or negative ions. This layer of positive ions or negative ions is called as L-Mode's electrical double layer. A difference of potential is then set up between the electrode and the electrolyte. When the metal forms metal ions and release the electron, the process is called as oxidation. That is, loss of electron is oxidation. On the other hand, when the metal ion gain electrons in order to form a metal, the process is called as reduction. Gain of electron is reduction, and hence a reversible reaction occurs. When the reversible reaction reaches the equilibrium, the potential difference becomes a constant value which is called as electrode potential. So there occurs an equilibrium between the oxidation and the reduction process. The forward reaction denotes the reduction process and the backward arrow denotes the oxidation process. So the electrode potential may be positive or negative depending on the position of the equilibrium. If the position of the equilibrium is more towards right hand side, then the electrode potential is called as reduction potential. If the position of the equilibrium is more towards left hand side, then the electrode potential is called as oxidation potential. Factors affecting electrode potential: temperature, pressure, nature of the metal. Here the position of the metal in the electrochemical series is considered, and concentration of ions. Single electrode potential. The single electrode potential of a metal is the measure of the tendency of a metallic electrode to lose or gain electrons when it is in contact with a solution of its own salt. Standard electrode potential. The standard electrode potential of a metal is the measure of the tendency of a metallic electrode to lose or gain electrons when it is in contact with a solution of its own salt of unit molar concentration at 25 degrees Celsius. Thank you for watching this video lecture.